human-sized entities.
I guess it is kind of hard to imagine cockroaches loading the dishes into the dishwasher.
Exactly. So we want to try and build machines that are able to easily interact not just with the human-designed world, but the humans in that world.
So when will we get to these intelligent humanoid robots?
So I believe that what's going to happen with this technology is you're gradually going to see very simple robots that enter the home and act as toys or help you clean the floor, up to increasingly sophisticated machines that you might see on construction sites that are doing things no more difficult than carrying objects from one part of the construction site to another, up to eventually humanoid robots that can carry out behaviors and sophisticated kind of behaviors like interacting with people in social and meaningful ways.
Boy, so we're going to have robot construction workers.
I believe that would be one of the most valuable aspects of this technology.
So if the robots eventually get to the point where they can do everything better than us, it makes you wonder why we're necessary.
That's always a very good question. And that was an important question that was being asked in the 80s when personal computers were starting to enter offices and people's homes. There was a real fear that computers were going to put everybody out of work. If we do realize humanoid robots, they definitely will change the kinds of jobs that we do, but they will definitely create jobs and change the world as we know it.
Dr. Bongard, thank you very much.
Okay, thank you very much.
Dr. Josh Bongard is with the University of Vermont. I'm Bob McDonald, and you're listening to a special edition of Quirks and Quarks, the national science program from CBC Radio 1. On today's program, we're speaking to scientists about how the ideas they're developing today could change our world for tomorrow. Not all the ideas we're discussing today are going to be high-tech marvels of engineering, precision, and ingenuity, like fusion reactors and robots. In fact, some of the technologies that might be most important for changing our world will have to be simple and inexpensive. That's because some of the world's biggest problems can't be solved by high-tech. They have to be solved with what's often called appropriate technology. Take clean water, for example. More than 1 billion people in the world don't have access to clean, potable water. And what this means is that these people are vulnerable to debilitating diseases that we in the developed world don't even think about. Using a handful of appropriate technologies to bring clean water to 1/6 of the planet's population could really change the world. Dr. Julie Zimmerman is one of the researchers hoping to slake the thirst of the world's poorest people. She's an assistant professor of green engineering at Yale University. Dr. Zimmerman, can you just tell us a bit about the problems the developing world faces because of a lack of clean water?
The biggest problem in the developing world is the link between clean drinking water and human health and social development. So we see a very strong connection between lack of access to clean drinking water and adverse human health effects. Everything from diarrheal diseases to stunted development for children, so height and weight and mental development, just a whole gambit of illnesses they're faced with.
Why can't we use just a single, simple technology to solve this problem?
So the reason that one technology seems to be very challenging in coming up with for drinking water challenges in the developing world is that there is a very strong cultural connection with the technology that's being introduced. So it needs to make sense for the community that you're working in. It needs to be based on local available resources for the technology development as well as for operating and maintaining it. So it's not clear to us that one technology is going to make sense globally.
Well, can you give me an example of some of the technologies that would or would not work in certain cultures?
So we're doing a lot of work in my laboratory looking at these plant-based materials for doing coagulation for treating drinking water. And it's very clear to us that the plant needs to be closely linked to the community that we're working in. So it doesn't make sense to take a plant from Mexico and bring it to Africa to do water treatment.
How does the plant work?
That's one of the great scientific questions that we're trying to address. So there's lots of great anecdotal evidence from these communities themselves that they've been using this plant matter for millennia to clean drinking water in the community. But understanding why it works and how it works and under what conditions make it applied technology that we can then transfer to other communities and have confidence that it's going to provide clean drinking water.
But